A rotation is, I did the Googling ahead of time this time, so we don't need to do it. I did it myself this time. Are you guys proud of me for being prepared for class this time? Thank you. All right, a rotation is a transformation that so these different things that we've talked about, like last time we talked about a translation, today we're talking about a rotation. Those are two different things that are each underneath the blanket of transformations. They're types of transformations. So it is a transformation that turns a figure about a fixed point. And the fixed point is called the center of rotation. It is a transformation that turns a figure about a fixed point called the center of rotation. So synonyms would be maybe like a spin. They said turn. Turn works for rotate. Anyone think of another synonym for rotate? We'll leave it there. Okay, let's move on. All right, so what we're going to do first is we're going to write down the coordinates for H, J, K, and L because we're going to use those. So what are the coordinates for H? 3, 7, okay. What are the coordinates for J? 8, 7, okay. Yeah. What are the coordinates for K? Okay. And then what are the coordinates for L? Okay. All right, now we're going to take the patty paper and we are going to lay it on top. And you are going to draw the y-axis and the x-axis. You're just going to trace them. And it doesn't have to be perfect because you're not turning this part in. This is to help you. So I'm tracing the y-axis and the x-axis. So see, I trace the y-axis and the x-axis. Everyone see that? It doesn't matter if you're using a color or not. Doesn't matter. You're just tracing it. Use your pencil. Go ahead and use your pencil. We are not using the colors yet. And then we are tracing the rectangle. And this is the original shape. Does anyone remember what the original shape is called? Pre-image. Marvelous. Yep, doing all of it in pencil. So this is what my tracing paper looks like now, my patty paper. That's what it looks like now. Yes. What is what? Carnegie Learning is a curriculum brand. It's like a type of textbook or whatever. All right. Have we gotten our tracing done? Okay. Okay, now here is how rotations work. The center of rotation is right here at the origin, so you're going to put the tip of your pencil at the origin, right there. And to do a, part B says to draw H prime, J prime, K prime, L prime in red. Oh, just kidding. Oh, well, it's part A and part B. See this? We're going to do part A and part B. It's the same thing. It says rotate the rectangle 90 degrees counterclockwise about the origin. So the origin is right here where I put my pencil. And when we do this rotation, we're going to get H prime, J prime, K prime, L prime, and we're going to draw it in red, okay? So we're going to go ahead and take this, and to do counterclockwise, we're going to go this way, okay? Everyone see that? We're going to go this way. And what we're going to do is we're going to go one full quadrant, okay? So watch me do it, and then you can do it with your pencil. So I'm going to take this, I'm going to spin it until the rectangle is in, this is the second quadrant, that is 90 degrees right there. I'm going to make it so it lines up. Everyone see that? Everyone see that? Okay, so, and then I kind of lined up my points so that they were on corners. Okay? All right, so now that my points are lined up, go ahead and make your spin. Everyone get their spin. I'm going to hold this nice and carefully. Move this up so that I can see what I'm doing here. And H prime is now left 7, up 3. Does everyone see that? Okay, so now I'm going to write this. H prime is left 7, up 3. L prime is left 4, up 3. J prime is left 7, up 8. And K prime is left 4, up 8. But what's going to happen as soon as I take my patty paper away? It's going to disappear, so what am I going to do with my red pen? I'm going to draw it again. Does that make sense? So the patty paper makes the rotations easier to do because it's very hard for us to visualize that. It's not as comfortable as the translations were last time. Those were pretty easy. This is a little bit harder. The patty paper makes it easy. We can kind of spin, we can see through the paper. We can at least write down the points, then we take the patty paper away. Now we can draw the points. So I'm going to take my red pen. If you are using a different color, mark out the word red and write down the color that you are using instead. Make sure that you mark down your H prime, your L prime, your J prime, your K prime. Aren't you guys so glad that I got the pad paper so you didn't have to try to do that without it? So worth it. Okay. Now, the way that we shorthand this, a rotation of 90 that is counterclockwise, we say rotation of 90. Counterclockwise is the normal way to rotate in math. In math, counterclockwise is normal. When you're telling time, clockwise is normal, but when you're doing math, counterclockwise is normal. So, and it makes sense because if you guys remember in math, I don't know if you guys have learned this before, so tell me if you haven't. What quadrant do we call this in math? 1. Anyone know what quadrant we call this in math? 2. What about this one? What about this one? So in math, we go counterclockwise when we do the quadrants. And so it would make sense that when we do our rotations, we follow that same counterclockwise movement, okay? So in telling time, we go clockwise, but in math, we do not, okay? So a rotation of 90 degrees means default counterclockwise. That's normal, okay? All right. Are we ready for the next one? Okay. So let's start back at normal. Start back right at the beginning. The next one is a 180-degree rotation. So if we want to rotate 180 degrees, how many quadrants should we go? 2. So which quadrant are we going to end up in? Okay, so I'm going to rotate 90 and end up on my red. And then I'm going to rotate another 90 and end up in quadrant 3. And I'm just going to be very careful to line up so I got my corners. And then we're going to write down each of our points before we get out our new marker. Okay, so I've got L is left 3, down 4. And since this is our second one, this is our second image, I'm going to do double primes this time. Okay, H prime prime, J prime prime, K prime prime. That way I don't get it confused with the other one. Does that make sense? Okay, so H, well, I was going to do L first. I'll do L first. Okay, so L prime prime is left 3, down 4, -3, -4. H prime prime is left 3, down 7. K prime prime is left 8, down 4. And J prime prime is left 8, down 7. Okay? And it says this one to do in blue. If you're doing a different color, go ahead and scratch out blue and put your own color in instead. For now, we're going to ignore the domain and range question. We're going to come back to that and do it for every single problem, okay? For this one, the notation that we would use is we would say R sub 180 degrees, so rotation of 180 degrees. Okay, let's do the last one. So start at the beginning. If we want to rotate it 270 degrees, what do you guys think we do? Go all the way around. 3 quadrants, right? 270 degrees. So we're going to go 90 degrees. Another 90 makes 180. Another 90 makes 270. So we're ending up over here. I'm just going to be real careful. Okay. All right, so my L triple prime this time is right 4 down 3. H is right 7 down 3. K is right 4 down 8. And J is right 7 down 8. This is the orange one. All right, how do we write this? How should we write this? Yeah. R270. Perfect. Okay. Now, we're going to add some notes here to the side. Don't worry, we're not writing very much. So, the domain of each of these problems is the inputs. And the input of each of these was the pre-image. We always started with the same thing. So the pre-image was what we drew in the first quadrant, because whenever we started the problem, we always put our tracing paper back to the very beginning. We always started there. So for each of these, I'm going to say, it's going to be tedious, but we're going to write it the same way every time. We're going to say our domain, and then we're going to write down these 4 points for the domain of every single problem. We input the same 4 points. We input the same rectangle for every single problem. So our domain was 3, 7, 8, 7, 8, 4, 3, 4. That was our input. The domain for the next one was 3, 7, 8, 7, 8, 4, 3, 4. We have the same input. The domain for the next one was 3, 7, 8, 7, 8, 4, 3, 4. So for each of these, we started at the same point for all of them. The domain is your input. The word range means your outputs. And the output changed every time because we did a different rotation every time. So for the first one, we had an input of the pre-image. We had an output of a 90-degree rotation. So our output was these 4 points. Does that make sense? Okay. I'm going to go ahead and write down the points that they correspond to. So it was -7, 3, -7, 8, -4, 8, -4, 3. So we have our inputs and our outputs. Was there a question? It doesn't have to be in that order, but it's going to help us in a second, because if you flip the page over, you can see that we're about to come up with some shortcuts. And the shortcuts are going to be easier to recognize if we know which one corresponds to which. Yeah. Okay. So for the 180-degree rotation, the input was this. The output was -3, -7, -8, -7, -8, -4, -3, -4. Okay. And then for this one, we had our inputs, our outputs, 7, -3, 7, -8, 4, -8, 4, -3. Okay. We will come back to those later because they're going to help us come up with our shortcuts. Okay. How are your brains feeling right now? Yeah, hands are cramping. Okay, take a stretch break. 1, 2, 3, 4. Stretch out the fingers. It's a lot of knuckles popping. Okay. All right. It says determine the coordinates if you were to do a 360-degree rotation. So we did 360 degrees. We would do 90, 180, 270, 360. What would the coordinates be? They would be the same as the original, okay? So I'm just going to do... You don't want to write quadruple prime? 1, 2, 3, 4. I don't know if it would be the Roman numeral or if they would do a 4 there. I'm going to do a 4. You guys can do the Roman numeral if you want. It'd be 3, 7, because that's the same. I could change up for each one. I should have Googled this ahead of time, but I didn't. 1, 2, 3, 4. The J would be, what would the J be? The same, which is 8, 7. Making you guys flip your papers. That's right, we're getting to work now. K would be 8, 4. L would be 3, 4. Okay. So we said the domain for every single one was the same because it was always the pre-image, right? The pre-image was the same. So let's go ahead and write down what the domain was. It was 3, 7, 8, 7, 8, 4, 3, 4. That's the input. And then what do we put for the range? It's the same thing. This time it happens to not change. Is that allowed? Yep. They can be the same. Input and output are exactly the same. Okay. Now, this says R -90. Clockwise. Okay. So we're going to take this, and we're going to go bloop. So 90 degrees clockwise is the same as what? 270 counterclockwise. Does that make sense to you? Okay. All right. So I'm going to say R negative 90 equals R 270. And then, do you guys want to write it down, or do you want to just leave it there? Let's leave it there. Okay, that sounds like just more work than I feel like doing. So where did we write the work for that? That was D. So I'm going to say C answers for letter D. So, and I'm going to write a note to myself that this is clockwise 90, which is the same as counterclockwise. Clockwise 90 is the same as counterclockwise 270. Hi! You can add it to the bookshelf over there. Yep. Okay. 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 Determine the area of the pre-image. So let's go to the original and let's do a little length times width action. Length times width. What do we get? 15. Okay. So we got 3 times 5 is 15. Okay, okay. What about the perimeter? Three plus 5 plus 3 plus 5. Okay. So we got 3 plus 5 plus 3 plus 5 is 16. Did I what? It's whenever they don't give you an actual unit of measurement, it's pretty common not to put one. You can do UN squared. And you can do UN. I'm sorry that I shocked you guys. Do you want a baby animal tonight?
Yeah.
No. You guys are sadistic. Man. Okay. Determine the area after of the image after a 90-degree rotation. Okay, so what's the area here? Is 15. Is the same. Okay, so but this one isn't 3 times 5, it's 5 times 3. Ooh. 15. Oh, look, she's being a rebel. She's still not putting the units squared. Because she's a strong, independent lady. Will the other images still have the same area? Yes. Why? Yeah, they have the same what? It's the same shape. They have the same side lengths. Okay. Yes, they have the same shape and side lengths. Okay. All right. Determine the perimeter of the image. What's the perimeter? 16 units. Oh, but not square. Well, 5 plus 3 plus 5 plus 3. She's going to be a rebel and just write 16. Answer is yes. I don't feel like writing out the reason why. I'm just going to say, yep, same. Ditto. Compare the measurements of the images to that of the pre-image. They're the same. Okay. Now, we wrote out this definition, I believe it was on Friday. Just in case you guys forgot the definition, I have it written down here. A rigid transformation is a transformation where the size and shape of the figure stays the same. Yes. Explain your reasoning. Size and shape stay the same. So that means that translations and rotations are both considered to be rigid transformations. We've learned about 2 transformations so far. They're both rigid. Okay. This is going to involve some page flipping. So we did that domain and range. Now what we're looking for is a shortcut. How can we do this without tracing paper so that we don't have to draw a graph every time we want to rotate something and get padded paper out and do it the long way? We want to be able to do it just from the point. So look at the points here. 3, 7 became negative 7, 3. 8, 7 became negative 7, 8. 8, 4 became negative 4, 8. 3, 4 became negative 4, 3. So what happened? They switched places and there was a negative added. Okay, so I'm going to go ahead and say, all right, they switched places. There's a y first and then an x. But what else happened? What changed? What became negative?
The first number.
Okay, so the y went to the first number and became negative. So the x and the y switched places, and the y coordinate became a negative. Okay, so we're going to say the x and the y switched places, and the y coordinate became a negative. So you're going to write negative y comma x, but I'm going to write that so it's legible. So that's the shortcut. Okay, now I want to add something to this real quick. So if we had a 90 degrees counterclockwise, what would that be clockwise? Negative 270. Let's add that just in case we ever need it. That would be negative 270 clockwise. So I'm going to write R negative 270. Okay, just in case I need it. I might not, but just in case. All right, 180 degrees counterclockwise. Let's look at this. What happened to these points? Yeah, they stayed, the x stayed in the x spot, the y stayed in the y spot, but both coordinates became negative. Okay, so we're going to write this notation is R180 of xy is negative x comma negative y. Now, we know these last 2 things are actually the same, so I'm not going to write this as a different line. I'm just going to do it right here. 270 counterclockwise is the same as 90. Oh, I shouldn't have put the negative here. Sorry, don't put the negative. 270 clockwise, the negative goes right here. Will everyone fix that for me? I should not have put the negative right there. The negative belongs like this. Did everyone fix that? This is 90 degrees clockwise. So we're going to say R270, XY, and then let's go ahead and look and see what happened to the coordinates. Okay, 3, 7, 7, negative 3. 8, 7, 7, negative 8. 8, 4, 4, negative 8. Yeah. Yeah, the X and the Y coordinates flipped places. They switched places. And the X coordinate, when it switched places, it became negative. So we're going to say Y, negative X. And then if they did the clockwise version, that would be R, negative 90. That's where the negative would show up if they did it. Okay, so you got some really good notes now. All right, how are your brains? Your brains are good. Brains are good? Yes? Okay. So, you've got some extra patty paper still probably if you need it. So if you end up having a brain fart at some point and needing to draw something for the homework, you can do that. The homework has a bunch of multiple choice problems. Just saying here is a single point. Convert it if you've rotated it this certain amount, okay? Let's go ahead and talk about this one. We didn't do the clockwise version for this one, but we should. So let's go ahead and take this real quick. All right, so if I take this one, I do counterclockwise 90, counterclockwise 180, it ends up over here, right? Let's do the same thing clockwise. Clockwise 90, clockwise 180, what happens? Same thing, okay? So let's add that to our notes. It's the exact same thing as 180 degrees clockwise, which is kind of convenient. Sorry, I forgot that one. Okay. We got our 3 shortcuts. We good? Okay.